Welcome to our session. We're going to talk about how build machine learning pipelines with SUSE. Today, we're going to talk about these four steps here, starting by introducing machine learning and the common architectures. After that, we're going to bring it to our ecosystem, showing how to approach SUSE solutions on that. To finalize, we'll do some real-time predicts. For those who don't know me yet, I'm Gabriel Lins from pre-sales team, based in Brazil. And with me is João Lucas, also from Brazil team. And it's a pleasure to be here today with you all, especially because it's our first session in SUSECON. So I hope that you all enjoy this moment and have some good knowledges. Before we start, I'd like to talk about how I got into this world of machine learning and share some of the few projects that I've done up at this subject. It all started in college, where I developed a sentiment analysis to predict the audience satisfaction for a program that we have here in Brazil. This program was made in Python using the usual libraries. Everything worked well, I was happy, but I debt with almost $306 in my cloud account. But okay. And now I want to introduce João to tell about his projects into this machine learning environment too.
So much, Gabriel. So I'm João Vale. I'm a sales engineer here at SUSE, and I work since 2019 with open source technologies, and I am a machine learning researcher as well. A few projects that I already developed was image segmentation to identify if someone is wearing the mask correctly, the face mask, and another one, which I think is pretty cool and pretty important, is how to recognize fake news among the huge data that we consume on the internet. Thank you so much for your attention here, and I hope that you get some nice deep dive info with us. So I like first just so I would like to start with an introduction to what is a machine learning, what is a pipeline, a machine learning pipeline. And this is something that happens with us all day because right now we consume many apps which uses machine learning. And a good example are streaming services like audio services. And I wonder if you ever thought to yourself, how do streaming services suggest good music that fits me so well? Like maybe you're feeling down or feeling not so good, and your streaming services starts to suggest to you some sad musics and some sad rocks. This happens to me all the time, and sometimes it happens that the algorithm suggests me music better than any best friend or family that I have. So all those algorithms running back on those apps tries to put all this data together and fits your personal info to suggest you great content.
Another field that we can use machine learning to is in the analysis medical exams. Here in this example, we are showing a picture of a lung, a X-ray lung that we are identifying if have some kind of cancer or maybe tumor too.
So, how do we create those models which can predict, for example, the audio streaming services or the medical services that Gabriel just said to us? So nowadays we're constant in contact with huge amount of data, and we can use this data to predict and understand, for example, how a user will behave on the internet. This is how algorithms like the video streaming or your favorite audio streaming services uses. It collects data from your usage and starts to predict using algorithms based on machine learning models. So when we analyze and transform all this data in information, we can start making predictions. Taking for instance what Gabriel just said to us, if we take many thousands of pictures of medical X-rays, we can start to understand how or maybe better how the computer can start to understand how a lung with pneumonia or with cancer is. So this is something that we can predict based on past data that an algorithm has been trained with. So it's like teaching something to a child. After you repeat over and over again, the child begin to identify the letters in other contexts. So you show the child the letter A many, many times, it will start to understand that A is in a billboard or some magazine or in the television, and it starts to understand maybe phrases or entire texts. So machine learning algorithm is like teaching a child, but the child here is your computer.
Nice. And with this huge data that we have access today, we can do, for example, an image classification. In this example here, we have images of cat, 1,000 of them. After that, we also have some pictures from dogs. When we teach our machine, when we training our model, in a certain moment, it starts to making guesses based on patterns, identifying if a photo is a cat or probably a dog, and all this. What we have if we don't have a good picture or a model not accuracy, probably we will have some problems like this picture that we have here.
Well, I like this cat dog, and this is something really relevant that Gabriel just said, because right now we're going to talk about the three main components, and one of the most important components here in machine learning pipeline is data, which is the source of information from you want to obtain patterns. So if you want to understand what is a dog and what is a cat, better not you but the computer. If you want to tell the computer what is a dog and what is a cat, you have to have clean data. You have to have nice pictures of dogs and nice pictures of cats, so your algorithm can start to make those identifications and understand that a cat has a pointy ear and a dog has not. The second important component here is feature. And what are features, right? So those are inherent characteristics of data that provide some information to the algorithm. So it's not enough if you just put some pictures of cats and dogs and tell the algorithm to understand. Actually, we can do it, but this is a little more advanced. But it's pretty easy for the computer if we take a picture of a cat and we just, for example, draw like a box in the face of the cat and tell this is a cat and this is a dog and this is a cat and this is the dog, because we can have like a huge picture in a city, for example, but the computer will not understand that, for example, a car is a cat and a cat is a cat. We have to tell the computer this is a cat, this is a dog, or this is a person, this is a car, this is a car, a sedan, this is a SUV. So this is where it comes this features part. You have to tell the algorithm which is the important piece of information that it should take in account in order to make predictions. And the third one are algorithms, which is the method chosen for task. We have many, many, many methods. I believe that you probably heard the neural network word before, which is a really advanced technique for machine learning. But we have simpler ones like classification, which is used for our email spam box. So an email spam box uses a very simple machine learning model, which is a classifier. So yes, it's every day in your lives. And I have here this nice example of a neural network, which is a technique for machine learning. And it can understand, for example, handwritten digits. This is a data set called MNIST. It's public, and we can take this data set, which is composed by many handwritten digits from 1 to 9, and you can tell your algorithm to understand how someone usually writes a 9. And it takes a picture, it cuts the picture in small pieces like pixels, and every pixel turns into a neuron in this network. All neurons have a weight associated to it. This weight contains the information for how much color it has or it has not in this specific pixel. So it starts to understand that a 4 has a pattern in the pixels that is activated. We can take it like that. So you can take every neuron that has many paths but only one output and starts to apply weights to those paths. So when you put this in many, many layers in a neural network, it can start to identify how, for example, for instance, the nine is handwritten usually.
So, uh, before we talk about machine learning, we have to understand data mining process. This cycle here is showing to us some cycle that has one start and some steps forward. The first one is business understanding. Starting with this step, we have to understand what does the business need, what I need, what I want. After that, we have, for example, another step named data understanding. This one is another specific step that we have to concern uh, to get our machine learning model, our process accurate enough. Here we have some questions that help us to acquire informations about our process, our machine learning, our template. If probably we don't have these questions or don't know how to answer these questions, probably you are dealing with a bad problem here with machine learning that we cannot use our data. Maybe they are not set it very well.
Okay, so taking a better look on what Gabriel just said, we can start making the whole process into small steps to understand what we should expect in the output. So the first step we call ingest, which sometimes we can call data scraping. So thinking for instance, imagine that you want to analyze tweets from Twitter and you want to understand if someone if actually if a whole population is enjoying a TV show that you produced. So you have to take all this data, collect all this information, and put into a data set. And this is what we call the ingest the data scraping. We have to communicate with Twitter, with the API, and collect all those tweets that we think are important for us. We can do this by keyword, we can do this by many, many ways until we find the necessary data for our usage. The next step is organize, clean, and prepare, which many times we call pre-processing. This is a process which you take all your data, you're gonna clean it, you're gonna prepare it, and put it in patterns which will be easier for your model to understand. After that, we have the test and validation, which we can use techniques like cross-validation before the training step, right? And when you do this, you create models that have the best input possible. This is why you use options like cross validation. And when you train a model using these nice data sets, you have an output, which is a machine learning model. Okay. So you're not going to take this model and put into the wild and test it and use it everywhere. You have to check if this is good enough, if it suits your business or your need. So you do what we call the data munging, the data preparation and wrangling, which is important here because sometimes you need to do tweaks and changes to get better metrics, better results. Um, as Gabriel said, we can have a better accuracy for a model that detects cats and dogs. And if you stay in this loop for a while until you get your better model possible, and after that, you can deploy, you can manage, and you can track this machine learning model and see if it suits well your application.
Cool, nice. So all this was to introduce what is machine learning, what is data, what we have to do with this data. And now we are telling about how we create a machine learning pipeline with SUSE. We are on the top of the world because we have some solutions on premises and cloud ready to give our customers or our client cut here again. So to introduce our this slide here gonna introduce our ecosystem that can use machine learning again. So now we're going to introduce how we can approach SUSE in our machine learning process. Here we have this picture that are showing to us that we have cloud native apps and on-prem and cloud ready solutions too. If, for example, we want to start using a system operation, we are okay because we have SLI micro here to use in our computer, whatever they are running on cloud, on premises, and even in Raspberries. After that, we have a solution to block storage too, Longhorn. Here we have a possibility to do read and write many, which is very, very important when we are in a shared environment, for example. If you intend to run your machine learning in Kubernetes, we also have some applications that we can create our cluster. This is RKA and K3S. On the top of this, we have SUSE Rancher working as a single pane of glass, administrating and orchestrating all your clusters and all your machine learning pipelines.
That's great. So taking all the SUSE technology and applying to an example of an architecture, we have something like this. So first off, we need to start doing our data scraping, and we can use Python, we can use R, and many other coding languages that are useful for this task. After that, you organize your data, you clean it, you pre-process it, and you have your data set. After that, you can put your data set in storage like the one that Longhorn provision. So you can use Longhorn to storage all this data that you collected from the internet, for example, for instance. And in this case, you run all this process after grabbing this data, which we call test and validation. This is a step that takes too much resources, and sometimes you might need a GPU or better and faster computational resources. So this is where we get like RKE and SLA to do this work, because you can manage this workload, and sometimes it's something that it needs too much power. And just to give some examples here, we have TensorFlow and we have PyTorch as some very important frameworks for doing this task. After that, and we get a nice output, which is a machine learned model, we can deploy our model for an edge environment, for example. So we can build an edge environment with K3s and Raspberry Pis, and we can do the inference step. So going back to what we said about cats and dogs again, imagine that for some reason you want to install some security cameras and you want to identify when you see a cat and when you see a dog. You can deploy this model, which knows what a dog is and what a cat is, to some Raspberry Pis connected to a camera running K3s. So they can gather all this information, and after that, you can output this information to a knowledge extraction page. This is the last step, which we call the inference output. You can take all the data that your Raspberry Pis and your devices collected and put into dashboards, for example, that tells you how many dogs and how many cats it has seen in the last week or in the last hour. This is a very silly example, but you can use this architecture to deploy very serious and very important models. For example, to analyze a credit card consumption. And if it starts to check if there is a strange information or someone might be using your credit card without your permission, it will check and red light that something's wrong, because the model already knows how you behavior with your credit card, and much more, like the medical examples that we gave before. So right now we're gonna check a very nice demo that Gabriel is gonna show us, which is a nice example of how to use a deep learning algorithm to check a very nice friend of ours.
So let's go. Here, I'm gonna change to my screen. Here we are seeing our OpenSUSE desktop, and we are in our dataset. I want to start here by show you how we did this step of our pipeline. The first step was take pictures, probably 1,100 of them, and put them in a folder that we can, after that, do a labeling process that we name. Here are my images, and all they are labeled too. To have our training process, we are using here YOLO YOLO is an open source solution to help us use these machine learning models and training our algorithms too. This is good because we have also some small types of models that can run in Raspberry, for example. So if you want to do an edge devices, an edge approach, we can use YOLO too. So here are our data and our trainings. Gonna minimize this window here to open our terminal that we're gonna run our model here. I'm calling this example here that are using our model that was training before, and we are using our webcam. This image size is to take note of the size of our image, and we run. Now, what we have here is my camera there, over there, and I'm here. So you are seeing our log that there is nothing happening here, all right? So if I start putting my first gecko here, I have one identified that is a standard one. This is good because I trained my model to do that. I'm differentiating which geckos I have. So the other example is another gecko that I have, the pine one. So here they are showing to us that is the pine one. Unfortunately, I don't have another one. So SUSE sponsored us, and oh, this example here show us how we can do this process using OpenSUSE and some of our softwares too.
Nice, that's great. I have a blue one if you want, but I not gonna give you for free.
Oh, damn. So this is all. I hope that you all enjoyed this session and have learned it too. And thank you very much.
Thank you so much for your attention. Thank you for being here. And I hope that you enjoyed the SUSECON 2022 and the many great sessions that we have here. Thank you so much.